Alright guys, taking a look here with you today on this Friday or Monday, whenever you're seeing this. Still wrapping a couple things up at home, just with everything that's been happening for the past couple weeks. So, wanted to introduce our new unit to you guys today, and you can see there in the front table is this notes packet. We've got a cute little family there. But we're going to take a look at this idea of quadratics. So this whole unit, what we're going to be taking a look at are problems, anytime we see quadratics, problems that have an x squared in them. Okay? And so that's what we're going to be identifying. We're going to, at least to start with today, we're just going to be identifying some basic features of this, right? Key features of it. Okay? And we're going to talk about intervals of increase and decrease, all right, especially when we're just looking at a graph. And we are going to do some basic graphing of it, but we're just going to use a t-chart of it. We're going to use the same 5 numbers every time to produce a graph. So far, we'll take a look at that as it gets a little more intense here. All right, so the first page, when we're taking a look at this, anytime that you have a graph that has an x squared, okay, it could look just like this. A, B, and C are just numbers. It could even just look like this right here, just with an A. Okay, it's got an x squared. It could look just like this. Right, still has an x squared. Anytime that you have that, we know that the graph is always going to have the same shape. Okay, that shape is going to be a parabola. Okay, just like with the absolute value. Anytime we saw the variable inside the absolute value sign, it always made a V. Okay? And that's no different here. It's going to make a parabola. We'll talk about what that actually looks like here. When you have a parabola, you always have a maximum or a minimum. Okay? That point is called a vertex, just like those V's. The vertex of the parabola lies on this line, the axis of symmetry. So I like how this right here pairs nicely with those absolute value. All 3 of these ideas, the shape of the graph always being the same based on what we see, in this case x squared, the vertex, the highest or the lowest point, depending on whether it's right side up or upside down, and that middle line are all from absolute values. Okay? We can see what an axis symmetry is. Remember, it's just an imaginary vertical line that divides the parabola into 2 symmetrical halves, right? So I could take it, and I could take my V, or in this case a parabola, and fold it in half, and it would lie directly on top of each other. Okay? It's always through the vertex. Now here's how I want us to look at this here. I want us to make a t-chart. Okay? It looks like we have 8 numbers here. Okay? Somewhere between these 5, at least to start with, will be good enough here. Alright? So I think the easiest number to do math with is 0. Right? So I'm going to take a 0 and I'm going to plug it in there. 0 times itself, 0. Let's do the positive. 1 times itself, Juan. 2 squared, right? 2 times itself. So again, we have to be mindful that we're not just multiplying it by 2, but we're actually squaring it. Okay? I'll come back and get the top half here in a second. But when I plot these, there's 1, 1, there's 2, 4. The next one was 3, 9. And the last one that I have here, at least in the positive, is 4, 16. Okay? Here's why the axis of symmetry works. And I know I could have gone a 5, I could have gone a 6, so it keeps going in that direction. Here's why the axis of symmetry works. If I look here, and we'll zoom in, it looks like at positive 1, it's 1 unit to the right of the vertex, right? The vertex was x was at 0. This one is x is at 1, so it goes 1 to the right. So this point should go 1 to the left. And if we just were filling out the t-chart right here, negative 1 squared, or negative 1 times negative 1, is positive 1 there. All right? Be careful, okay, when you use a calculator for these right here, because a lot of times, if you put negative 1 squared in, and then not just with this fancy calculator, but any of them, negative 1 squared, see how my answer is negative 1? We know that's not true. You have to use parentheses in order to square something. All right, we know that a negative times a negative is a positive, right? So be careful in the calculator. Let's see if we can keep going here. I know what negative 2 squared is. It's going to be a positive number. Let's see if that's the case. At this one, I went 2 units to the left, so I'm going to go 2 units to the right. So see how it's kind of shaping up just like a mirror around the vertex. Okay, it has to shape it up around the vertex. The next one here, 3, would be a 9er. I went 3 units to the right for this y value, so I'm going to go 3 units to the left. Okay, and I could keep doing that to build it. Notice how it's almost like this line right here that my pencil's on is the mirror. Okay, it's almost like this pencil is the mirror for my parabola. Okay, looks like it probably should have gone a little more through that point. All right, so we're going to talk about, over the course of this unit, 3 different ways to write the quadratic form. The first way that we're going to talk about here is vertex form. Vertex form, if I write this here, you might notice how similar it is to things we've seen in the past, right? That looks very similar to that absolute value, right? This is not it, but this was for the v right here. It was y equals a times the absolute value of x minus h plus k. Okay, this one right here is for the parabola. Why is this helpful? Well, just by looking at it, it's really helpful to find the vertex. Right? And we know that the vertex is a key point in order to tell us what the highest or the lowest point we might see. I could also use that same equation and go to standard form. All right? In standard form, it just looks like this: ax squared plus bx plus c. Okay, this is really helpful, especially to find the y-intercept. Okay, to always find a y-intercept, we know we could just plug in 0 for x, and we always get c right here. Okay, ax squared, bx, and c. And then the last one is factored form. Okay, factored form, it looks like we would have already factored it. Factored form is helpful because it has x-intercepts at q and p, whatever number is in there. So maybe it was like x minus 2. X-intercept would have been positive 2. Maybe it was x plus 5. X-intercept would have been negative 5 right here, right? So all of these can be used to represent the same equation, but we just have them organized differently. So in short, make a t-chart. If you're asked to graph it right now, just make a t-chart, right? 5 numbers, negative 2, negative 1, 0, 1, and 2. Be mindful that if I see something like this, 2x squared, I have to square it, then multiply it by 2. Okay, I have to square it, then multiply by 2. All right, so here are some key features that we're going to be looking for. What I want us to do to start with is, just by looking at a picture, seeing what happens with the graph. All right, so we got a graph here in the upper right hand corner. It says, what's the vertex? Remember, the vertex is either the highest or the lowest point. Okay, it looks like it doesn't have a highest point only because it's going to go up forever, right? So the lowest point here is at 3, comma, negative 1. Is that a maximum or is that a minimum of this graph? Because it's right side up, it's always a minimum. Okay? Roots. That's just another name for x-intercept, right? We'll talk more about that a little bit later, but synonyms for x-intercepts are roots, zeros, solutions is another one. Okay, all of those can be used in place. So where does this graph cross the x-axis? It looks like it crosses at 2 and 4. So, again, you could do it a couple ways. You could list it as a comma, right? Notice there's no parentheses there. A parentheses would make it a point. Okay, you could, that would say x equals, right? You could say, or you could use those braces, right? Not brackets, not parentheses, but braces just is a list of numbers. And that way we're just listing that. Okay? Axis of symmetry. X equals, and it's always this line that divides the parabola in half. And to be honest with you, it's always going to be the x-coordinate of the vertex. So if we can find the vertex, we should be able to find the axis of symmetry. Okay? Now the domain and range here. We want to be a little bit aware of what's happening. Okay? We want to go back to this picture here. And when I'm looking at this, remember the domain. Okay, we want to be thinking about it as what happens on the far left and the far right. So look at here on the left-hand side of my graph. It looks like it keeps going to the left. Now it doesn't do it very fast, right? But you can see that this graph is going to get wider and wider and never stop getting wider on the left-hand side. Okay, so we have to keep that in mind. It looks like it's going to go forever. Looks like it's going to go forever here on the left. Same idea on the right. It looks like it's going to go forever there on the looks forever on the left, forever on the right. So there's a couple ways that we can organize this here. We can do it in interval notation, right? We know that that was just negative infinity to positive infinity. Or we could express it in inequality form, which is something that we've gone back and forth with. And if that happens, it's just the phrase all real numbers. Okay, all real numbers. Now, right here, if we're looking at a range, okay, again, we could do it in interval notation. Right? We could do it in interval notation, or we could do it in inequality form. Interval notation is what happens, the range in interval notation is what happens at the far bottom of the graph. So I can look at this here. I'm looking to see at the bottom of the graph, when does my graph start, right? Because it's definitely not there at the bottom. It looks like it starts at negative 1. Okay? When does it stop going up? It doesn't, right? So it looks like it's a hard cap at 1, but then it goes up forever. The inequality notation would just be y is greater than, why the letter y? Because we're talking about the range, greater than or equal to negative 1. Okay? So we're using that picture to help us out here. All right. Let's take a look at number 2. Number 2, we have a vertex here. The vertex is either the highest or the lowest point. It looks like here, because it's upside down, unlike here, looks like because it's upside down, it's a maximum. And that maximum is at 2, 3, 4, 5, 1, 2, 3, negative 5, negative 3. My zeros, my x-intercepts, where does this graph cross the x-axis at, right? Where does this parabola cross the x-axis? There are none, right? Sometimes it doesn't happen at all. The axis of symmetry, remember, it's always an x equals line. X equals the x number of the vertex. So x equals negative 5. The domain, remember we have it in a couple different ways, the interval notation or inequality. You may notice that in this one that the graph is also not going to stop getting wider. So that would be negative to positive infinity. And then we could also use the phrase all real numbers. The range, again, we want to stop at the bottom or start at the bottom always. Okay, it looks like it's never going to stop going down. So it's going to start at negative infinity, and then as I work my way up, what's the highest number that it reaches? Oh, it's the vertex again, right? -3. Okay, so that's something that we need here. Notice the correlation between the x number in the vertex and the y value in the vertex as it shows up throughout. Okay? Again, the range in inequality format, it would have just been y is less than or equal to -3. Okay? So here's what I want you to do. There's 4 more here. Try what you can here. Maybe it's just getting the vertex, right? But pause this video here, and I will do the same, and see if you can fill out what you can from each of these. Alright, so you guys can see here what we have. You might have noticed a pattern there. For all domains, it's always going to be the phrase all real numbers, or if you're writing it in interval notation, that negative to positive infinity. Okay? Where the range actually includes a number from the vertex for that, right? Again, sometimes the vertex, like number 5 or number 3, sits directly on the x-axis, right? And so that's nice when it just tells us exactly what we have there for that. All right. So let's take a look here at the bottom section. It's just these 4 questions here, and it says the graph of a quadratic function is a straight line. Well, if we go back here and look to see how many straight lines did I have, I didn't have any, right? So that's never the case. The quadratic or the range of a quadratic function is all real numbers, right? Has the range always been all real numbers? It never has. The quadratic function can contain the point 0, 0. Has that ever, so has this graph ever gone through 0, 0, or could it? Yeah, it could right there. Sometimes right here at number 3, it does include the point 0, 0. It doesn't have to. So that would be a sometimes here. And the graph of a quadratic function opens upward, has a minimum point. So let's find all the upwards. Upward, right here for number 1, has a minimum. Another upward has a minimum. Yes, so that would be always true for that. All right. One last key idea, okay, and that's all about increasing or decreasing. All right. So we're going to take a look at basically what's happening with this here. So the ability to describe a behavior of a graph is important here. In this lesson, we're going to learn how to analyze the graphs of the functions. A function is increasing when it rises from left to right. So I'm going to use this ruler here to think about this. If I were to, with my index finger and my thumb, basically, and I'm using the ruler to exaggerate this, touch and follow the line, see how the ruler has basically, like if I think about it as a line, as a positive slope right here, right? So that would be its increasing. Okay. The function is decreasing if it falls from left to right. So if I were to continue this path here, notice as I approach and reach the vertex and then get my hand out of the way here, it looks like now it's going down, right? The slope was negative on that ruler. Okay. And so let me see if I can use a pencil. Maybe that would be more helpful. Okay. So again, as I'm looking at this here, it looks like the slope is positive with the pencil, but as I approach the vertex and then go down, looks like that would be a negative slope. Okay. And that's kind of a very fundamental thing about calculus, and we're not doing calculus yet, but this whole idea of finding lines around different shapes. Okay? So if I says what is the interval for the functions increasing? So it looks like for increasing, we know that it had to have a positive slope. So on the far left hand side, when do I have a positive slope? Well, look at this. It looks like it's positive all the way to what x value? The x value is 0 is when it stops, right? So it's increasing from negative infinity to 0, not inclusive, right? It's not increasing at 0. That's when it actually went horizontal. For it to be decreasing here, again, I could do the same thing. It's everything after 0. So decreasing would be everything after 0. And again, because of the arrow, it's approaching it. It's just decreasing forever after that. What is the maximum or minimum value? We think about this at the vertex being the y value. Okay? So right here is the vertex. We know it's 0, 3. So that means it is a maximum at 3. Okay? It has a maximum value at 3. Alright? And that happens when I'm switching it from a increasing to a decreasing, right? So notice at that point, right there, it switches from an increase to a decrease. That's when it became either a maximum or a minimum. All right, so let's take a look at this one here. Now we're not dealing with a parabola here. Notice it's just a line. Okay, but for what intervals is this function increasing? So it looks like if I just take it, it looks like it never stops increasing, right? When it's a line, that might be easier to tell. So what interval? So it started on the far left and it continued forever on the far right. Okay, as x gets bigger, so is y. As x got bigger, so is y. As x gets bigger here, y is decreasing for that. Okay, same idea with that slope. It's never decreasing for this. Is there a maximum or a min? Remember, that can only occur when it goes horizontal there. And so no. And just kind of even a review, how can I tell if the graph is a function? Okay, if the graph passes the vertical line test. Alright, so let's take a look here at one more thing, and let's just kind of go through the domain, the range, the function, increasing, and so on. Alright, so we know for this, it looks like, and it doesn't show it here, but there should be some arrows. So the domain would be from negative to positive infinity. Oops, sorry about that. Looks like it would be from negative to positive infinity, right? There should be arrows there. The range, remember, we always start from bottom to top. So it looks like the smallest number is 2, and then it goes on forever. So it starts at 2, and it goes on forever. All parabolas are functions. Okay, all parabolas are functions. So we want to think about this here. When is it increasing? When is it decreasing? So I'm going to start on the left, and I'm just going to follow this here. So see how it looks like it's decreasing? And as we get to the bottom, it looks like here it's increasing. Okay, so it looks like it's increasing from everything from 0 towards infinity, right? From everything here as x got bigger, y was also getting bigger. It's decreasing from negative infinity to positive infinity. Okay, so when we talk about domain and range here, we want to be aware that we can use basically, okay, what's happening here on the far left? Well, the arrow is going to keep getting wider, so I know it's negative infinity, all the way to the far right, and again, this arrow keeps getting wider, not very much, but I know it's going to be approaching positive. And then we have it right here where we're looking from bottom to top. So bottom, it starts at 2, and it goes on forever. All right. In this one here, notice there's no arrows on purpose for this one. Okay? right here when we're looking at this, it appears that the first domain number, the first x value, is at 2, right? And so I'm going to have to count it here. But there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So 2 to 13 inclusive. The smallest value, it looks like, is 1. And then I want to count it up here. 2, 3, 4, 5, 6, 7, 8. So 1 to 8. Again, it has to pass the vertical line test. It looks like there's only one part of the line here that's touching it. Right there, it kind of gets a little iffy, but it doesn't touch it more than once. Same right here. It doesn't touch it more than once. Okay, so we're good. It's functioning. All right, now this one, not designed to be a challenge, but it is a little more difficult here with the increasing and decreasing. We're going to use that same idea when we think about this here. So it looks like from 2, which is where I'm starting here, it looks like it's going to increase until I get to this point right here. So it's increasing from 2 to, let's see here, 1, 2, 3. So 3, 4, 5. 2 to 5, it's increasing. All right. Now, not quite sure here, but it looks like it's going to take a turn down, right? So at 5, looks like it starts decreasing. When does it stop decreasing, right? So let's think about this here. Let's see if I can position the camera to make this a little bit better here. All right, so we can see this here. It looks like it's horizontal, and I'm going to have a negative slope. And when does it start or stop being negative? So it looks like it's going down here with this, and then it flattens out a little bit. It never stops going negative though. See how my slope is still negative? And then it flips it back down even more negative. So from this whole interval right here, from 5 as an x number, it's going negative, it's getting smaller right there. Okay, so 5, 6, 7, 8, 9, 10, 11. This point right here from 5 to 11 is when it was decreasing this whole time. Now we can see it's going to switch and go back up at 12 and 13. So notice I have my union from 11 to 13 here. Alright, so it looks like anytime you have multiple things of increasing or decreasing, okay, we won't have those on a parabola just because I know there's only one turning point, one max or one min, where here there is a maximum and a minimum. Alright, let's try it one more with just something that looks like a parabola here. Alright, so we have this here. It looks like, and if we can't see that, this is -2, -5, and 4, 7. We're looking for the domain and the range. The domain, the smallest x value would have been -2 all the way to 4. The smallest range, be careful, don't just always go with the points here, but it looks like it's right here. That's the smallest. So it looks like it's including -9 all the way up to +7. It is a function. It's increasing from -2, and the vertex appears to be at 0 here, to 0. And then it's, excuse me, I said that wrong. It's decreasing on that point, right? So from -2 to 0, it's decreasing, and then from 0 to 4 is when it's increasing. All right, so we're going to be looking at some of these intervals here for today. Keep in mind that whenever it's asking you to graph something, just use those t-charts, right? Make a t-chart. On most parabolas, it's going to have you graph the vertex, right? On MathXL, it's going to have you graph the vertex and one other point, right? So if you graph a vertex, and let's say it's y equals 7x squared, I have my 0, 0, so I can plot that point. And if I put in this number right here, I could just graph the point 1, 7, right? So make sure that you're getting those points. doing that. All right, I will see you guys on Tuesday or Wednesday.